Hey there, I'm Chroma, and today I will be showing you how to move a 2D character in Unity. We will then use this to create a simple physics-based side-scroller. This tutorial is at a beginner level, but assumes you have at least played around with Unity before. Ready? Let's get started. In a new Unity project with the 2D settings, we will start by creating our player and ground. Even though we are making a 2D game, we will use 3D objects, so that we can stay within Unity and don't have to worry about making 2D images in other programs. In the hierarchy, we can create a 3D object, cube. Without the depth, you can see this is basically a square. It is very dark though, because when dealing only with 2D images, or sprites, we do not need any lighting, but when dealing with 3D objects, we do. Let's create a light by right-clicking and selecting Light, Directional Light. We will rotate it to 0, 20, 0. Now that we can see our cube better, let's rename it Player. We will now give it some color. I have already made a few folders to keep things organized, and in the materials folder have created 3 materials for the different things that we will be coloring. Let's drag this green player material onto our player. Be aware that this will not work in the game view and must be done in the scene view. Speaking of which, let's set up our camera. We will change the background to an almost black color and we'll increase the size to 10. Now, let's make the ground for the player to sit on. We will duplicate the player cube and move it down to -3 to be the floor. Then we will change its scale to 100 to 2 to stretch it out. Let's rename this cube to Ground. Then change its color by dragging our ground material onto it. With our scene set up, we can now start working on our player. We will be using Unity's built-in physics engine to move it, so we will add a rigid body component. Go to Add Component and type Rigid Body. This will also allow it to fall under gravity. Now let's get input from the user to move it left and right. In the already created scripts folder, we will right-click and create a new C# script. We are using it to move the player, so let's call it Player Move. We will double-click to open it up in Visual Studios. Starting off, we will need to get a reference to the rigid body component of the player so that we can push it around with physics. We will make a private variable of type rigid body that we will call RB for short. We will also create a variable for the speed the player will move with public float speed. We can then, in start, get the reference to the rigid body with RB equals getComponent, and then in angled brackets, type rigid body, and then 2 round brackets. Now we will move the player in Update. Because we are going to be using physics, we will change the name of Update to Fixed Update. Simply put, this will make the physics calculations a lot smoother. We will use the A and D keys to move left and right, so we will first need to test if the user is pressing one of those keys. Starting with right, we will type if input.getKey keycode.d. If the user is pressing the D key, we will run the code in between the brackets. To move the player, we will use our rigid body variable and use the function addForce. The force we will add will be vector3.right multiplied by our speed variable. The speed we will have to set in the inspector will be quite high, so I will add a ×10 to lower it. Now we want to move in the opposite direction if we are hitting the A key, so let's copy this code and change it slightly. We will change D to A, then vector3.right to vector3.left. We will also add an else, so we can't be pressing both directions at the same time. Let's save and return to Unity. Now let's add the script to the player and set the speed to 5. Running the game, we get interesting results, as our cube moves left and right, but turns and bounces. Maybe this is the type of behavior you want, but we want our player to slide across the ground. Going out of play mode, we can fix this by constraining how the cube can move and rotate. On our rigid body, we can expand this constraints dropdown and see we can freeze how it moves on a given axis. We will check freezing the z-axis as we do not want it to move forwards and backwards at all. Then we will freeze every rotation as we want the player to remain upright and not rotate at all. Testing this, we now see our cube slide instead of bounce. You can also see that if we let go of the button, we take quite a while to slow down to stop. If we are not moving an ice cube, we can make the player slow down faster by increasing the drag value on the rigid body. Now we stop faster, but we also move slower. We can then increase the speed to compensate. Be aware that any changes you make in play mode will not be saved when you exit, but it can be a good place to experiment with different values. Making a good feeling player is all about fine-tuning values like this. I found that a drag of 3 and a speed of 15 works for us. I will go out of play mode and type these in. With this drag increase, you may now also notice that if we raise the cube up and hit play, it falls a lot slower. We can speed this back up by increasing the strength of gravity. If we go to Edit, Project Settings, and go to Physics, we can see the default value of gravity at -9.81 on the y-axis. We can increase this a lot to say -20. Now we will fall a bit faster. Now we have a moving player, but as a bonus, let's create some crates that we can push around. Let's create a new cube that we will name Box, then move it around and rescale it. Now we can give it a rigid body, so it too will act under physics, freeze its movement along the z-axis, as well as its rotation along the x and y axes. Then we'll give it a color with another material. We can then duplicate our box and move it around. Hitting play, our boxes fall down, and if we move into them with our player, we can push them around. We can even make the crates lighter to push around by going to their rigid bodies and decreasing their mass. As well, we can do more to our environment by duplicating a ground piece and turning it around to be a shallow slope, or become a wall. We can also make a rolling crate to go down the slope by creating a cylinder, rotating it, and then doing the same to it that we did with the first crate. With the rigid body, we want to freeze the X and Z rotations instead because of the way that we rotated it initially. We have coded so little, and already there is so much you can do with this. If you wanted to have the camera move around with the player, you could simply drag it under the player, but I will leave the camera stationary. Lastly, let's make things a bit more organized by making some empty game objects to store our crates, rolling crates, and environmental objects like floors and walls under. And now we have a movable 2D player. We will cover jumping in the future, but I challenge you to use the creative constraints of not being able to jump to make something unique. I hope you found this tutorial helpful. If you have ideas for tutorials that you want to see, please suggest them in the comments below. Thank you for watching, and I'll see you around!